Hello everyone. So today we have Codeforces Round 796. It is a Chinese round, and I think the Chinese round is happening after a long time. Let's see how it goes. Also, the scoring distribution for today's contest was quite impressive. So yeah, let's see. Positive integer x, minimum positive integer y, which satisfies the following two conditions: x and y is greater than 0, as well as x XOR y is greater than 0. So it will be greater than 0 if minimum positive integer they want. So like in the given number there has to be at least two set bits, right? One and three. Oh, so yeah, there has to be at least one set bit, and then so oh, in case of 0 only, there is no need to check for this condition. Then the answer would be so basically the first bit which is set right in k equal 1 while n greater than 0 if n and 1, and then let's then do k plus equals to 1 left shift cnt and this and yeah, just right, and yeah, I think this is it. Oh, so 1 left shift 0 is 1. Okay. I think this should be 3 followed by 3. Okay. So if CNT is greater than 0, then do CNT minus minus, is now CNT plus plus. For 5, oh, for 5 we have 1. For 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1. So for all odd numbers, the answer no, not for all odd numbers. So like n is 1, then the answer will be 3. If n is then if n is odd, the answer would be 1, and in the other case yeah, wait, the answer is 64 for this case. Oh, we know. Oh, because it is not binary. Am I missing something else? Okay, so I have an idea, right? Except this thing is right. Or no. If n1 XOR k plus 1 left shift CM2 is greater than 0, then just do this and break. Right? No need of this condition. Why it is doing this? Oh, Yeah, I think this should be good. Right? Yeah, I think so. Let's see. And magical tokens, their magical power can be extended with a positive integer 7 to an. May perform the following two operations on the tokens. Chooses two tokens and removes them. Creates a new token. Magical power equal to the sum of the two chosen tokens. Token with an even value of magical power adds. Removes it, creates a new token. Okay. So, tokens are more effective when their magical powers are odd values, helping to find out the minimum number of operations make the magical powers of all tokens odd values. Okay. I mean, so if there is even one odd value, then I will just use the first operation, which is fusion. So here it is 0, here it is 1. Yeah, this case is tricky. Okay, so I think I can solve this one as well. And this case also can be solved just by the workplace. Right now, mod 2 is 0, right? And do pp plus plus cnt is equals to minimum of cnt comma, and let's just say it is 16. Then we should see what cnt is. 0 1 oh yes, so this plus and minus 1. Right? Yeah, I think that's one. Oh, it can be one. I don't think it does anything good. String s of length 1 initially. Following operations n times for the ith time uses a non-empty substring t2i minus 1. She replaces this with a non-empty string t2i. Note that the lengths of these can be different. Okay, so if it is A, okay, so we can replace that anywhere. After n operations, an operation sequence T of length 2n. Shuffles the order of T. We didn't get much from the statement. Let's see the examples. So in the first line, we are given next 2n line contains one non-empty string Ti. Next line contains one empty string S. Let's see the problem D as well. Can be represented by n points on the x-axis numbered 1 through n. Okay. Used magic to detect the initial number of mushroom on each point. Okay. At any point in the forest, minutes 0, she moves from point X to Y. Okay. She collects all mushrooms on point Y. A new mushroom appears on each point in the forest. Okay. Maximum number of mushrooms she can pick after k minutes. So at each moment, doesn't matter she collects mushrooms or not. The following happens in order. Okay, so in the same minute you can move and as well as collect mushrooms from the. So she is starting. Oh, start out at any point. Okay. Start out expects then collecting losses as well. Now in this case, however, yeah, it should start from 9. 3 plus 3 plus 3, 9, then 10, and 10 is 37. Dot 2, 2, 3, 2, 2, 2, 1, 2, 2, then 3, then 4, then 4. return. So 6 plus 1 7, that's 1 8. Ten plus 9 19 21 plus 4 25 35 plus 8 33. Oh yeah, so this is even number. No time in the simulus problem. Non-empty string, which is the final string. So we are given A, B, B, C, D, and A, C, D. Initially has a scale. In the first operation, chooses A and replaces it with AB. Okay, this becomes AB. In the second operation, she chooses B and replaces it with CD. This becomes ACD. Replaces it with AB. Okay, so A must be present in the original string, right? So if we do backtracking, I think that will, in the other case, Z then A, Japanese, then Y, K, U, M, R, N. Okay, so RAN is replaced. RAN should be replaced with Japanese, right? Yeah. But then there is no A. Or maybe just replace A with A. Oh, so maybe this Yakuma instead of being the Yakuma it was Y double E K U R A N. But they are saying that it started with a Z. Oh, chooses A and replaces it with when oh, so like what thing was it is uh, so this T array is the main thing. We need to construct at least these more in the order. Shouldn't be like it kind of feel like a DR plus. No? So this is equivalent to saying that there is an edge from A to Ren and A we have to move, right? And there is an edge from Z to A in. So is it also like it started with a string of length 1? So as initially length 1. Okay. Like it could be any value from A to Z only. So if I do it in brute force here, then I will start with A and so like in this case I will choose A and replace it with what? only 76. Okay, so how much can we feed this to? Three minutes. Is this the same one? First to find the string helpful in finding the initial string in any way. I don't think so because like for ACD, how will I ever know that initial string is A? I think it is a graph problem in which we just need to construct that graph and just value determined dynamically at initially it is A. So yeah, initially like all edges are possible. Let's say an edge from A to AB, B to CD. Now if we are saying that there is an edge from A to AB, then the next edge could be from like B to CD. This is valid. Like from CD to B, it would not be valid, right? Okay. Now, if we say that there is an edge from A to B, then from B, oh, so B cannot be in the next year after. Okay, and the same case is the initial edges from A to CD. but it is also very hard to find, right? We'll have to generate all of the substrings. If I go from the M, and I was having a CD, so I can, share that CD is to replace with something else. But even the A should be replaced with something else. Like maybe was replaced with A, with AB, and then we can say B, C, D. And then if I replace CD with B, and probably B. There was an interactive problem also, right? What was it? Yeah, this one is empty. The railway system of Tokyo is finally finished, and stations and bidirectional tracks connecting them. Ith track has length Li. Due to budget limits, the railway system may not be connected, though there may be more than one track between two stations. Okay. Value of a railway system is defined as the total length of its all tracks. Maximum capacity of a railway station is defined as the maximum or minimum value among all of the currently functional systems full spanning orders. There are two competing definitions. A cyclic subgraph of the given graph. Or a graph consisting of a spanning tree in each connected components of the graph that spans all of the vertices, meaning only that each vertex of the graph is a vertex in the forest. Okay. Okay. In brief, okay, is a simulator only able to process no more than 2 queries. Input of the simulator is a string s of length m. A system of characters 0 or 1. The simulator will assume the ith track functional if si is 1. Okay. The device will then tell the maximum capacity of the system, the simulated state, minimum capacity of the system with all tracks functional with the help of the simulator. Structure of the railway system is fixed in advance. In other words, the interactive 1000 queries will be there and 1000 of this ith track is functional if SI is 1. It's the total length of its all tracks. The minimum capacity is okay. When first, second, and third one are functional. Then the minimum capacity is 5. Ah, okay. So when none of them is functional, we have 0. When first, second, and third are functional, we have 5. That's the minimum capacity. If all of them are functional, we have 9. Problem C has more cells. Okay, then let's not go for the E problem and the problem. Is there something obvious that I'm missing? From A to AC, what all things can happen in A plus C plus D at the same time? What could have happened in the last operation? Something which gives me either A or AC or C, CD, D or ACD. Like that. The value of k can be updated at one. So how to handle multiples? Five, 6, 1, 2, 3. So firstly, I should see that how the answer is coming out of it. 37 for distance. It tells me to start from 2, go to 6, then 4 to 3. It gives me 3, I think. 3 or 2. Okay. So initially it was 6, then again 6, no, then 2. Then I go back to 6, which will give me 1, I think. Right? Then I go to 5, which will give me 8, then to 2. We I have to 6 plus 2, and 2, right, then 1, okay, then again 2, then 2, 3, then 4, and then 20, 30. What? We got the answers 42. 5, 6, 1, 2, 3. Okay. And then I go to 3. And then back to 2. And then back to 1. Oh. And then to 2. And 3. Four and 5. Still. So it starts with 2, but like at minute 0, it cannot collect the machine set points. So -6 it will be 37. Yeah. So one thing that I realized is that, let's say, oh, so once it has collected all of the mushrooms, it should just travel linearly, right? So since it was 7, it started its journey with the 1 having a modulo equal to 2, something like that. 7 mod 5, 2 mod 5, here it will be 2 mod 1. So at the first minute it will collect the machines of point 0, then we will wait up there. Here, yeah. Minimum value of take and minimum. So if I say that it should start at the point which is having the maximum number of mushrooms, then it will start right and will wait on 6. Okay, so if it does it like that, then 1, 2, 3, 4, and 6. Let's say it goes to the left, then to right. And then again right. Again right. Again. Then go to the 16 plus 420, but 20 plus 14 is 34. If the value of k is less than n or even equals to n, then some window of size k will give me the answer. Otherwise, just take the modular, right? I mean, if the value of k is more than n, then it will be optimal to traverse the whole array at least once, isn't it? Yeah, I think. Let's see. K mod, right? Okay, then some prefix, some suffix. Let's this. Right. Yeah. So here means two cases. One case is this one, and the other is generator. So sliding window and okay, and less than or equals to this. Answer equals to maximum of answer comma prefix of I minus prefix of I minus k, right? And just answer. Oh. So in the smaller cases also, that will not be optimal. Okay, answer plus n into n minus 1 by 2. No. K into k minus 1 by 2. Right. And in the other case, the answer will be it can be right. And now some prefix or suffix prefix of mod plus 1 minus p of 0, I think, p of n minus 1 of p of n minus p of n minus 1. But it's the same thing, right? Does this change anything? K into k minus 1 by 2. Same thing. Nope. Eleven plus 6, 17. Okay. Then 7 into 6 by 2 is 21. So if I like take 5 in the first attempt, and then I take 7, it will become 1. Oh. So when I take 5, it will become 1, 7, 2, 3, 4. Take 7, it becomes 1, 3, 4, 5. Take 3. And 5, 6, 1, 2, 3, 5. It becomes 1, 7, 2, 3, 4, 7. Now I will have to take 1. Right? Then 2. So it becomes 11 plus 5, 16 plus 10, 26 plus 13. So that doesn't work. 7 into 6 by 2 is 21, and the sum of the initial array was 17. That's why it was giving me 38. But it should have given me 7 less. and also like this can be replaced just here. So if I somehow like find a relation between the sum and that thing, it will be the overall sum is 17, the answer is 37, so in total need 20. N into n minus 1. Or in that case it is like it is 40 by 2. And maybe it can also be broken down. Yeah, n into n minus 1 by 2 is to be there, right? Like 1 and 2 and what? Yeah, 1 to 3, 3 plus 3, 6, 6 plus 4 times. Okay, so that is like 5 into 4 by 2. So the sum plus n into n minus 1 by 2 plus more, which is also equals to 10 only. Even to 4 by 2, but what if like 8 operations are allowed? Oh, so not this, n into n minus 1 by 2, and now that modular thing comes into the picture. Right, so if the modulo is, okay, that's 2m plus plus plus, and then m will become equal to actually we don't do this. So plus equals n minus m plus 1 into, so I need the sum of n minus m plus n minus m plus 1, so on up till n. Okay, answer plus equals to n into n plus 1 by 2 minus n minus m into n minus m plus 1 by 2, right? And plus m into m minus 1 by 2, like this. Missing something. Like for this case, oh, number of rounds. So I think that is easy to calculate. Yeah, just this thing. Or actually no. Ln c equals to k by n. So it can be 1 also, and that case will not handle. So k by n minus 1. In this case, I will do n into n plus 1 by 2 plus c, right? No, into c, right? Still this value is wrong. This should have been really easy case to handle. 349. For this case, I think so we'll do it like in the brute force way. Will be 5 into 10 to the power 9, right? And then I will have to do n into n minus 1 by 2 is one thing, right? K by n. Oh, maybe this value at the end is causing trouble. But why though? And if wrong answer in this case also. So my answer is smaller. Okay. If I don't do this, at the time of first linear traversal, I am doing plus 2 plus 3 up till n minus 1, right? N into n minus 1 by 2. So if I like forget about this thing, one 4 0. Okay, the difference is this. So it is just 2,80,000 by 2, right? And that is like k into 2. Oh, so the value is c is this. If I don't subtract 1 from it and just multiply it by 10. What is 10 in that case? 5 into 2. And what? Oh, so I am adding this value still. No way. So this value has to be added, right? Let's not care about this for now. After that, this is what I'm getting. Okay. Three, 4, 9. Okay. Multiplied by 2. 6, 9, 8. Oh, maybe that modular thing. Like I will have to traverse once more here. Just like I did in the other case. Oh, so this is the problem. Like when I'm doing n into n plus 1 by 2, that value is increasing at that time also. Oh, so like in the end, let's say all the values initially were 1, 1, 1, 1. Let's say 4 values were there. So I picked up this value and became 1, 1, 2, 2. Then took this value, 3, 3. Then I took this one, 2, 2, 4. Then I took this one. Okay, now in the second traversal, it will remain as 1, 3, 4, 5. It will become 1, 3, 5, and 6. It will become 1. Plus 5. It will become 1. So this one and this one and that one, these two and these two. Zero, 1, 2, 3. Not 0. Okay. So this much thing is right. Then do n minus 1. Now here 4, 3, 2, 1. Then after one traversal, it will become 1, 2, 3, 4. But in one cycle, it will give me n into gave me 1 plus 3 plus 5 plus 7. Which is 12 plus 4, 16. 4 into 4. And yeah, now just the last piece. Continuous this, and then I will take 1. Then 1 and 3, 4, 5, 6. We'll take 3, 2, and then 1, 5, 6, 7, and then 5, 7 and 9. How much is this? 9, 18, 25. Okay, so just answer. And into 9. Right? And this time is no overflows. Shouldn't come down. Yeah, everything's available. Yes. Problem C, I am still not able to think about any solution. It's like any graph kind of thing. In this problem, I use to visit like any string which occurs more than once will never be our answer. This is right. After 10 operations, screen got the phone. I mean, can't take the try. Or maybe I don't know. The C and T of x of 0 minus t. So C and T of pi is C out I plus 1. And yeah, one of the characters will be there. Wait, what? What happened in the? Oh. Then mm, maybe the system. So all of the strings are like A to Z. Only those characters can be our answer, which are given to us in the input, right? Now it can occur more than once also. It can occur more than once also. Like one case could be I'm replacing A with A, then again A with A, and final string is also but that doesn't make much sense. I don't think that is right. Then what will help? So like in this case, I had started from A, but like in this case, if I had started from B, you have to replace it with AB, right? maybe starting from B doesn't give an answer. Because at the end there will be one B remaining, and that B cannot be replaced with anything. So I have to start with a A. I have to solve this problem. But like there are many cases where it is not. Let's think about those cases immediately getting the answer. So one case where it could fail, like initially I had D, I replaced it with AB, then I chose A and replaced it with CD. I got BCD in the end, right? Or CDD. So if I had started from A, I'm having A. You replace it with CD. Then I took AB, or then I took D and replaced it with AB. So what I'm doing basically is that I'm reducing the array by 2. I'm removing 2 strings. Yes. Oh. So if I like start from here and just say that this CD can be replaced with A, for example, then I'm having AB and this AB can be replaced with B. Okay, that is fine. If I say that this D can be replaced with anything, let's say A, but I should not choose A, right? Yeah, I should not choose A. But in this way, like there are many possibilities. So I don't think the problem requires us to solve that. Standard definition string exists. Can be shown that definition string is unique. So there cannot be multiple initial strings, like multiple answers does not exist. Z, A, A. But there is no relation between the string that we are choosing and the string we are replacing it with. I don't know this one. Okay, in the last round also I was not able to do the C problem. I did the D problem, and today also I wasn't able to do the problem C. Okay. So problem A, B, and D. So this problem, I don't know the shortcut to solve this problem, but how I solve this problem is, let's, oh yeah, I think I should show it from my submission, like what I was thinking of here. So first I converted all the numbers into binary, and I figured out which is the least significant bit in the number, right? So for example, for this 5, the least significant bit is just 1. Now what I did is just that, so since the number can contain only 30 bits, to the power 30, I just like XORed it with each of those powers of 2's. So like first I checked it with 1 XOR 1, and then yeah, just checked their AND and their XOR 1 and 1. If like the condition is satisfied, then I am okay to go. Otherwise, I will like check for the next power of 2. So in this case, since this is 0, I will go and check for the next power of 2, which will be 1 XOR 2, and this will be greater than 0, and 1, and so first I will do 1 plus, how did I do this? So like first I added the value. If we just take this least significant bit, so in this case the least significant bit is just 1, the value of like one left shift least significant bit, so 2 to the power 0 basically, which is 1. So if I just take this one, this will never give me the correct answer, right? because, or maybe it will also give me the right answer. So in some cases it will give me the correct answer, but if it does not give me the correct answer, then what I will do is that I will check, I will add first 0, then I will check on the AND and XOR conditions, then I will add 1 to it, plus 2, plus 4, plus 8. So basically I'm just setting the bits one by one. So first I will check for this number, then this number, then this number, and so on. And if like initially it was, I don't know, maybe like it was 4, then I will check for 1. First I will check for 100, then 101, then 110, and 100 we have already checked, then 1100. This way I will do this. So the main thing is that there can be only 2 set bits in the final answer. At max there can be only 2 set bits, and if there is like only 1 set bit, then I think that will be the least significant bit of the given number. So let's just quickly look at the code. So yeah, here I am finding out the least significant bit. CNT will be having the like this position of the least significant bit, I would say. Then yeah, I'm just checking for all the 30 bits. If K XOR N1, it's like if the initial value, the least significant bits value, is giving me the correct answer, then I'm okay to go with. Otherwise I will add 1 bit, like each bit one by one, and then I will check the XOR as well as the AND. And if I got an answer, I will break out the loop and print out the. So this one I think a bit harder for the level of diff 2As, but I think it was doable. Then problem B. So we are given a list of values A1 to AN. We can perform 2 types of operations, either fusion or reduction, and at the end all the values have to be odd. So again the value will be odd. So in the fusion operation we can combine 2 values. So you can see that it will be optimal for us to use this fusion operation if we are having 1 odd value and 1 even value. And one more important thing, we need at least 1 operation to convert any even number to an odd number. So like if we are having a 2, then if we do the reduction thing, it will be 2 by 2, which is 1, and yeah, it is odd. And if we don't do the reduction thing, we do the fusion thing, then we need an odd number, right? So 2 plus, let's say 1, it will be 3, which is. And so yeah, this is a good thing that they added this test case here, this corner case. So when all of the values are even, then we can prove that after a number of reduction operations we'll be having an odd value. So like in this case, if we convert this 1 to an odd value using this reduction operations, it will take only one operation. 4 will take 2 operations, and 8 will take 3 operations. And similarly in this case, I think I can also show you how many operations are there. So the first number will take 10 operations, 10 reduction operations, then next one also, and the third one will take 8 reduction operations to become an odd number. So we will reduce this number, obviously. Why to waste 10 operations when we can do the same thing in 8 operations? And after converting it into an odd number, we don't need to convert the remaining 2 numbers into an odd number using this reduction operation. We can then use the fusion operation, and we will just print out the minimum number of operations to convert any even number into an odd number plus the remaining number of numbers. So that will be n minus 1. This one was an easy problem. Definitely an easy problem. I think it was easier than A for sure, at least for me. And then yeah, this problem D is interesting, but again, math based problem. So yeah, today I think most of the problems were related to math only. Like I don't know how to solve problem C, but well, I think that is also not related to DS. So what is this? I don't know. So there are only two cases, when k is less than or equals to n, and the other one is when k is greater than n. So in the case when k is less than or equals to n, the answer will just be the sum of any subarray of length k. Of not any subarray, of the subarray which gives us the maximum sum. So in this case, the value of k is just 2, and the subarray sum. Okay, so I can show you for this. So yeah, the subarray sums are 5, 11, 12, 14, and 17. So subarrays of length k of length 2. So the sums will be 11, then 7, 3, and 5. So the maximum sum is 11 of subarray of length 2. So the answer will be that maximum sum of all subarrays of length k plus k into k minus 1 by 2, which is the extra mushrooms we will get at each operation. So since it was given to us that for this case only, if we take 5 first, then 5 will become 1, and all the other values will be increased by 1. Then when I take this 7, it will become 1, and all the other values will be increased by 1. So the answer will become 5 plus 7 equal to 10. Now when you do the calculations and derive some formula, you will get this thing, that we are adding only k into k minus 1 by 2, right? And similarly this thing also. So how I did this, I don't know if you will understand or not. I did some calculations like this, some more calculations like this, and eventually I get to the answer. So in the end, I just figured out this pattern in which we were adding just n into n and multiplying it by c. So basically what was happening is that, let's say we have an array 1 2 3 4, and when we traverse this whole array 2 times, so let's say the value of k is 8, then at the end we will be having only n into n, which is 4 into 4. We will add only this thing, and yeah, this thing we will add twice, I think, right? Yeah, I think we will add this thing first. 4 into 1, 1 2 3. Yeah, so we are just adding 16 into 2, which is just n into n into c, where c is 2 and n is 4. So this was again just a pattern, another math based problem, and this is the last case. So like when you have visited the array and some operations are still remaining, so like in this case, and the value of k is 7, so you can traverse the array at most once, still you are having 2 operations left. So if you do some math, you will get that after traversing the array once, you will be adding the values, like I wrote it up here upwards also. So you will add the values n minus m, n minus m plus 1, n minus m plus 2, and so on up till n. So like in the first case, the modulo was 2, so I was adding values 3 and 4, I think, right? No, I was adding 4 and 5, I think. Yeah, the modulo was 2, but I was adding this and the overhead of 1, so it was becoming 10. So I think it starts from n minus m plus 1, then plus 2, plus 3, and so on. So first I like calculated the sum of the first n numbers, then yeah, this is correct, n minus m plus 1. Then I was subtracting the sum of first n minus m numbers. So like before this we were having this number, then n minus m minus 1, and it was starting from 0, right? So the sum of this, so like the sum of the whole array minus the sum of this one. Here this is it for this round. I still don't know how to solve this problem. Maybe I look at the code of someone. I will this one. But okay, let's see. For each character we are just counting that how many characters are giving how many times. But what? Really? So the first number whose frequency is odd is our answer. Really? So A occurs twice, B also occurs twice, C and D only once. Where is the scope? And yeah, in the last case also, A, C, D. So the occurrence of A is 3, B is 2, C is 2, D is also 2. So the answer is, don't know how these legendary guys got out the answers so fast. And in this case, the occurrence of A is 4, 5, 6, 7, 8. So this way A got eliminated. Again, U also got eliminated, Y also got eliminated. O and N and yeah, Z on the other sides. So maybe I was also right. No, it was way off. I don't know. This is it. Bye.